my name is Imran and I'm a senior data scientist at Consortium. Today, we are going to do object detection by using Opencv. Let's get started. So in this video, we are using Jupyter Notebook, which is integrated with the Python language. So first of all, we need to import the Opencv library like this way. After that, we have to import the image, so we can import the image by using Opencv. So here we need to give the path of the image, which is jpg. So after reading the image, we need to show the image. So let's check that what are the objects in the image. So we can use matplotlib to show the image. So we can import the matplotlib like matplotlib dot plot dot pyplot as plt. So we can use plt dot I am show image and then simply plt dot show. So this way we can show the image. So we can see that we have 6 cars in this image. So we can detect all the cars by using image. As we can see that the colors are not accurately, so let me just because in Opencv convert the color to BGR, but we wanted to see in the RGB format, so we can convert the image into RGB like this way. cv2 dot cvt color, and then we can feed the image, and then we also need to give another parameter, which is color from BGR to RGB. So after doing that, we have to do the same thing. I am show RGB, and then we need to plot it. So we can see that now the colors are clear, but in Opencv we need to convert the image in grayscale, so we can apply some image processing techniques. So let's convert the image into gray. So we can use Opencv, and then we can feed the image, which is RGB. We can use Opencv to convert the image color from RGB to gray, and we can show the image like this way. plt I am show. We can feed the image, and then we can show the image like this way. Yes, so still the image look like it's not in a color form, so we can make cmap is equal to gray. So we can see that now the image is in a grayscale. So after that, what we need to do, we need to apply some techniques to clean the image so that we can easily extract the objects like these cars from this image. So first we are going to do the Gaussian blur. So what is actually Gaussian blur? Well, Gaussian blur help to remove the noise, the small noise, like we can't see that. If we zoom this image, we can see the noise here. So, and then we will apply the thresholding on the image, and we will try to get the objects by using Opencv. So first we need to apply the blurring, so we can apply the blur like CV2, and we can use the Gaussian function, and we can feed that gray image. Another parameter is the filter, which filter we wanted to apply on the image 5 by 5, so it will be 25 by 25 dimensions of the filter which will be applied on this grayscale image. And here we set 0 because we wanted to get the image as output in a grayscale as well, like a binary image. If we wanted to get in the RGB format, so we would be giving 3 here. So we wanted to get in a grayscale, so we can also check this image by using this code here. So here we have the blur image. Let's check. It's still giving that there is no name of Gaussian blur. Alright, so there should be AU. Okay, so we can check the image in a blur form. So now we wanted to apply some more techniques. Now we will apply the thresholding on our image to get the binary image as a black and white. So to do this, we need to apply the threshold function on our image. So here we need to give our blur image, and we need to set the criteria that, like, if the image, if any pixel is less than 200, that will be 255, and if that is greater than 200, so that will be 0. So actually we wanted to do the binary thresholding, so because we wanted to get the background as of black and the objects as white, so here we need to apply some Opencv functions, which are trash, binary, inverse, and also we wanted to apply CV2, trash, or OTSU algorithm, which is actually an optimal algorithm. So let me just show this image what we can get. So here is some issue. Okay, so we need to, because this threshold function returned the 2 values, but we wanted to get only one, the threshold one, so we can do like this way. So you can see that now the background is black and the cars are in a white color, so that's good. Now we need to fill these black holes so that we can get these objects properly. So to do this, we need to apply some more things. So we will apply structuring elements on the image, and we will apply the dilation on the image to fill these gaps of the cars, and we will also apply some kernel on it by using that dilation so that we can fill these big gaps and the small gaps in a good way. So first of all, we need to set the kernel. So we can set the kernel by using Opencv get structured element. So we can apply some techniques like morphology, morph, and morph rectangular, and also we need to define the filter size. So we, let's say 7 by 7, we can apply 7 by 7, and then we can apply the dilation on it. So by using Opencv, we can call the dilate function, and we can feed the image, threshold image, and the kernel that we define, and then the iteration. So iteration means how many times we wanted to apply this dilation. So let's check the image. Dilate cmap is equal to gray. Alright, so I think again there is name issue. Get structured, it's not structured, it's structuring element. So we can see that the gaps are filled, but still there are some of the gaps which we need to feed. So we use 7 by 7 filter, so we can use the bigger filter so that we can fill all these gaps as well. Like let's say 21 by 21. So let's check. Okay, great. So now we can see that we filled our gaps in the cars. So now we can clearly see that where are the cars, so we can get these cars. Alright, so now we will apply find contours by using Opencv, and we will get the contours of these cars. So let's get started. So we can use Opencv dot find contours. Let me just correct this, and then we can apply we can set the dilate image that we get above, and then we need to call the Opencv dot rdr return external, and we need to call cv2 chain approx sample. So this one we are calling from here, which we dilated, and this function actually get the contours, the external contours, like it will get the values of all the external locations of the car or the objects, and this one actually select the optimal contours. If we use the approximate none, it will be giving a lot of contours. I mean that it will be giving a lot of dimensions for the objects, like it will be selecting this thing as a different object, this thing is a different object, it will be giving a lot of things. So that is why we are using here simple, so that we can get the useful contours. Like we wanted to get only 6 contours of this image, as the find contours give the two return the 2 parameters, so we need to set 0 here because we wanted to get the first parameter, and then we can check the length of contours, or you can say that the length of object. So now we can see that there are total 6 contours. It means that it is giving us the 6 locations of the objects. So next we can draw the bounding boxes over these cars, so we can see that our Opencv is working fine and detecting well these objects or not. So now we can use these contours, and we can draw the bounding boxes over these cars, and we can get all these cars detected. So let me just use a for loop here, and we can use, and we need to get the coordinates and width, height from the image, so we can use Opencv2 bounding rect function here, and we can the feed the contours coordinates, and then we can use Opencv rectangle, and we can feed our original image. We can give the starting coordinates, and we can give the ending coordinates, which are x plus w and y plus height, which is height. And then we can also set the colors, like 255 we can set the color, and we can also set the thickness of the bounding box line. So let's check with one here. So after that we can get the region of interest of the images. So we can use the original image, we can get the y here, and also the width of the image. So we can get the region of interest of these cars, and then we can plot them. So let me just run it. So it is saying that rectangle. Alright, so there are spelling mistakes every time. Let me just do it. So now I can use show image tld dot show. So we can see that we have the bounding boxes over the objects. Okay, also if we wanted to extract any car from here, like we wanted to extract the cars from this image, and we wanted to track those that car, or we wanted to do any kind of work, so we can also extract that object and we can track them as well. So let me just extract. So first of all, let me just I need to get the coordinates of all these car bounding boxes. So I'm just saying that images. Okay, so I am going to save images dot appending. I'm going to append the region of interest here. So now, for example, if I wanted to get any image, so I can use show images, and I can get any image, like that we save the coordinates of all the images in the images variable. So now we can get any, like I'm going to get the first image, so I can so you can see that we are getting this car. So if we wanted to get this car, we can also get the same way, like we can use here one, and we can use this car. And if we want to do this bigger car, we can just simply use this one, and we can extract this. Even we can use these coordinates, or we can use these features to track this car. Even we can do the same things by using the video, and we can perform all these tasks, because that we also need to convert the video into frames, and frames are just like images. So we can do frame by frame these things, and we can detect or track any kind of object. So if we wanted to save the image, we can also save. So we can use cv2 dot I am right here we can name the image big car and the extension like png, and here we can set that which car, so on the fifth number. So like this way we can save this car. So this car is saved now. So if we wanted to know that where the where the object is in the image, so we can draw the contours and we can know that what is the location of this big car. So first we need to import numpy and then p, and we need to create a new image so that we can draw the contour on this new image and we can check that the location of this big car. So we can create the same dimensions of the image. After that we need to call cv2 draw contours, and we can feed this cimg, and then we need to call the contours and we need to give the number of the contour, and we can set the color of the bounding box, and then the thickness of the bounding box, and after that we can show the image cimg plt show. So we can see that this bigger car is in this location. I hope this video was informative for you and you got some concepts and solutions here. Please get connected with me so you can get more updates on my channel and you can get more useful videos.